x to the second to the third to the second, third, second. What is this? Is this a joke? It's not a joke, but you'll think it's a joke because it'll be that easy in 10 minutes or less. Check out the video. All right, so we're gonna start out with a bit of review. So when I look at this right here, what's the exponent? 2. This is 3 to the second. It means 3 times 3. Right here, if there's no exponent, what exponent can I put in there? 1. 4 to the first power, it means literally I just have 4. Here, same thing. I can put in an exponent of 1. So that means x. Next, to multiply powers, add exponents. So as long as you have the same base, you can add those exponents up. X to the second times x to the third, well 2 plus 3 is going to be 5, so that's x to the fifth. Here I have q times q to the third. Now remember, if there's no exponent here, just like we went over above, that's going to be q to the first. Here I already have an exponent, it's a 3. 1 plus 3 is 4, so this is going to be q to the fourth. Now right here, I do not have the same bases here, so I can't do 3 plus 1 and get a 4. It's not going to be x to the fourth or y to the fourth. I have different bases. So I just write it like that, can't simplify, it's done. So what we're going to go over for today's lesson is how to find the power of a power. In order to do that, all you have to do is just multiply the exponents. So for example, if you have an exponent and then you have an exponent on that, all you do is multiply these. So 2 times 3 is going to equal 6. Well, why is that? Well, let's use a variable that isn't used that often in math textbooks. A happy face. Suppose I had happy face to the third power. Well, remember, the exponent tells you how many times this is written in a multiplication problem. So this would be happy face times happy face times happy face. Why are there 3 of them? Because I had an exponent of 3. Well, now let's suppose instead of having happy face to the third power, I had x to the second to the third power, and I'm still going to put this in a circle. And the reason why is because I want to show you the similarity here. This is going to be x to the second times x to the second times x to the second. See how instead of having happy faces 3 times, I now just have x to the second 3 times? And now that you have this like this, remember what we did last lesson. When you multiply and you have the same base, what do you do to those exponents? You add them up. So if I add x to the second times x to the second times x to the second, 2 plus 2 is 4, plus 2 again is 6. This would be x to the sixth. Going back to the original problem, 2 times 3 is 6. So this is the reason that this is true. So let's take a look at the difference between this concept and the one that you learned last lesson. Here, I have the same bases and they're being multiplied with exponents. X to the third times x to the fifth. Here I add the exponents. 3 plus 5 is 8. Here, notice I have the base written only one time. I have an exponent on an exponent. Anytime you see this and there's no base here for this exponent, that's when you multiply. 3 times 5, 15. And that's the difference. All right, so let's take a look at a few practice problems just to make sure that you understand this perfectly. Here's that nasty problem from the intro video. I've got x to the second, to the third, to the second. Now hopefully this doesn't look that bad anymore. I have a base here, but there's no base here. That's just a power. No base here, that's just a power. So what do I do with these? Multiply. 2 times 3 is 6. And then 6 times 2, 12. So this is just going to be x to the 12th. Again, just multiplying. It doesn't matter what order you do it in. 2 times 3, 6. 6 times 2, 12. 2 times 2, 4. Times 3, 12. Doesn't matter. Either way, we get 12. Here, when we do this one, remember, if there's no exponent on a variable, that's right, put in a 1. Now, this one, what's interesting is you multiply, And when you have multiple variables in here, think of it like distributed property. In other words, we're going to have x to the first power, and that's going to be times 2. And then we have y to the third power, and that's going to be times 2. So what this is ultimately going to be is x to the second, y to the sixth. And for those of you scratching your head who don't feel like hitting the rewind button, all we did was distributed property. 2 times 1 is 2. 2 times 3 is 6. That's it, done. This problem right here combines what we learned today and what we learned in the last lesson. Here, 3 times 2 is 6, so I have x to the sixth. I still have that x to the fourth. Now, see how I have a base here for both of these, and the bases are the same? What do I do with these exponents? That's right, I add them up. 6 plus 4 is 10. So again, power of a power, multiply these. I know because there's no base here for this 3, so just multiply them. 2 times 3 is 6. That's how we get this. The x to the fourth I just rewrote here. 6 plus 4 is 10, and the reason why I added them is because we had the same base. If you understand all those, you should be set. Hope you enjoyed the video. Don't forget to hit like and subscribe.